Hi everyone.
Hi, Vanita. Good evening.
Hi, ma'am.
Hi.
Hi, sir.
Ravi sir will join in few minutes. So once he is done, one of you please save the recording and send me in a mail. Okay.
Hi, students. Hi. Thanks for.
Hi, sir.
Hi, sir.
Hi,
Okay.
sir.
Hi, hi.
Hi, sir.
Um. All right. So let's finish the remaining questions. So there's. Uh, oh my God. Okay. All right. So I think we went up to the first list. Question number 20 was complete, right? Can hold occur at placement stage? If yes, do we move to the next stage? If no, why? Right? We answered that question. Didn't we?
Yes, sir. We completed.
Okay. So then we'll go to the. So you can, Pooja, you can keep adding um, whatever I state here. So you can add that those answers to those questions. So how can we decide area of floor plan? I think this is the next question. So what was the? I had given some explanation. Any answers for this?
Netlist area
Sorry.
based on netlist area. Based on netlist area.
Okay, based on netlist area, how will you decide the area of the floor plan? So the first point to be made before you answer this question is, so let's talk about block level floor plan. Okay, first. So the way to answer is, okay, first we can discuss the block level floor plan, then if required the top level. So how do we decide the area of a floor plan, block level floor plan? Let's say netlist is of 5 mm square. What will be the area of the block? what will be the area of the floor plan? If netlist is 5 mm square. Okay, so I think you are not revisiting, whatever I'm stating, many things you are just hearing and forgetting. So let us say there is 2 mm square of hard macro and 3 mm square of standard cell logic. Okay, just an assumption. Now, what should be your initial? So there are actually few important things when you actually talk about block level floor plan. Okay, and two aspects which we actually discussed was, as I said, standard cell logic and hard macro. The crucial part about this is it should be already DFT inserted. Okay, so let's crack one at a time. So first thing, assume that the block is DFT inserted and every logic is present, and then you are actually trying to come up with the area for your block. Then if there is a 2 mm square of macro, then it would be safe to assume, like, the hard macro will not have much area to add except for whatever blockages and some routing issues. And depending on, let's say 2 mm square is made of 100 macros, then some floor plan, abutting, spacing, all that. So you should start with an assumption that about 80% or 90% of utilization for the hard macro. Okay, so that should be a fair assumption. So 2 mm square divided by 0.8, which will be like, what would you get? You would get about 2.4, 2.5 mm square of area for the hard macro. Similarly, you look at 3 mm square of um, uh, standard cell logic, divided by, you can say, first initial trial you will start with like 60%. Let's assume that. So if that's your start area, then you would say 3 mm by 0.6, which will be like 5 mm square. So put together, it is 2.5 mm square of hard macro area plus 5 mm square of standard cell area. So that's about 7.5 mm square should be the size of the floor plan, right? So this is assuming, all DFT logic, etc. inserted. Now let's add some variables. Let's say you have a lot of feed throughs, okay? And let's say probably 10,000 feed throughs and, concentrated in certain area. Then you may have some losses, but you will have to justify them based on your PNR results. Okay. And, so that's one thing that you will have to say how the growth is before you ask for additional area you have to look at. So feed throughs will have an impact in terms of your utilization. So you may not be able to touch 60%, maybe 50%, maybe, if the number of feed throughs is really very high. And, and especially you have like, few of the special cells coming, one variable at a time. Feed throughs having repeater registers. That means there is going to be some registers added from the top level. Then you will have to actually make provision for that. Okay. So first assumption, if there are high feed throughs and if there are going to be some registers addition, then they will get added into the standard cell area, and accordingly you will use a utilization whatever is going to come. Second assumption, let's say DFT is not present. That means, the flops are not of scan flop type. Okay. If they are normal flops, not of scan logic, then you need to actually convert them to the scan flop, and roughly the scan flop to normal flop could be area jump of up to 50% in the flop area, right? So you'll have to look at that, flop area, jump in that case. So you'll have to provision that your standard cell area, in which, let's say, 20% is the flop, then 20% is going to grow by 50%. That means, 20% will become 30%. Okay, so that's the initial standard cell area you need to compute. Are you understanding? I'll show you through an Excel sheet. This station. You need to look at that. So the next variable could be, let us say, what else we could think? All right, DFT accounted MBIST. MBIST and all, depending, on the congestion, the grouping only you need to change. Yeah, the clock cells, for example, if there is going to be top level, some TMAC is getting inserted, or there is an overlay cell which is coming from the top, which is going to actually occupy some amount of routing spaces, then there is going to be a problem. Now, what I'm stating is, for, let's say, a metal stack, which is actually about 8 or 10 metal stack. Now, if your metal stack is only 5, and already your memory is occupying up to M4, then you don't have routing resources. You cannot actually abut. Okay, so one of the key aspects that you have to look at is also in terms of the metal stack, assuming that there is over the macro routing possibility, etc. So when you answer, all these possibilities can come into deciding a floor plan. I think you are giving them a know-how that, there's no one table that fits all, right? So there are variables and you are going to consider them. So that's the way it is. The other variable could be that, let's say it's a low power block which is going to be shut off. That means, there are going to be empty CMOS or power gating cells which are going to get added into your design. All right. If there are going to be isolation, then that's going to get added into your design. If that's not there already present in your initial net list, okay, and all this power connectivity is going to happen at the time of power architecture, then these are all additional areas which you need to actually account for. Then if there is going to be spare cell insertion, which is of 1%, then you'll make provision for them into your utilization scope. So I think you have to answer like this and state that, not everything divided by 60% or not everything divided by 50%. That's not the way to answer. These are all variables which is going to come. So your standard cell to this one, and then you are going to look at how the scope is going to improve. And let's say initially you have started with 60%, then suddenly after placement, your area growth is going to happen at 75%. Why? Why should that happen? Because you have to actually see that, streamline that your final utilization should not be more than 70%. But some blocks are tighter. It can go into 80% also, but then, a lot of automation, etc., need to be properly done to be able to account for that. Then comes the final variable, which is the shape of your block, right? So now you have actually discussed what should be the size of your floor plan. Now suppose, from the top level, the shape cannot be rectangular, can't be square. Okay, will be thin and narrow. Then again, you have a problem, right? So what needs to happen is you won't be able to place the macros, where you are desiring. If there are notches, some of the notches may become unusable. So you'll have to try and actually pack them adequately. But the start utilization will be like this. But sometimes, there could be impact on floor plan because there are notches, because no DFT inserted, because there are feed throughs, because the metal stack is low. All this could impact your initial assumptions. Is that clear?
Yes, sir.
Okay. Next. Question number 22. Check design, check timing. I think this question I had answered initially itself. You know, uh, so what does check design do? Let me see if you have actually again taken them. So in sanity checks in detail, I've already explained what you do with check design, check timing. Can somebody answer what you do in check design? What's the difference between check design and check timing? What does check design do? Well, you are not doing your homework. So,
It mainly
Uh,
checks the
In check design, it will check for undriven outputs, unloaded inputs,
floating
and if
undriven
tri-state
output.
cell, any tri-state cells.
any
Huh?
tri-state cells are present.
Mm.
Floating inputs, floating pins.
Floating inputs.
Floating inputs.
Mm. So that's what you call undriven inputs. Okay.
Yeah.
If
Yes, sir.
outputs are not
Undriven
driven, what
inputs.
do you do?
Outputs are not driven.
Unloaded outputs.
Yeah, unloaded output means what can you do about it? If outputs are not loaded, okay, so you can in fact delete
Connected
that
to
cell.
ground.
Okay, they don't need to occupy any area, so you can clean up all those cells. But I'll tell you, when you are looking at check design, you have to look at actually, um, you know, like removed register list. Okay, for example, as I said, as you stated, unloaded outputs means some of the registers outputs are not loaded, so those registers may get cleaned up by the design, right? If they get cleaned up, let's say register gets cleaned up, then subsequently the cells which are connecting, they become unloaded, and if they don't have any other logic, they get removed, and we will get actually good amount of area recovery there. So if that does happen, then you have to actually verify that if those registers which are removed are fine to go with. Okay, because sometimes what happens, you won't be able to verify without those registers. The verification, and the design team may be having difficulty in terms of actually ensuring the design sanctity. So you have to get a front end approval specifically for removing those registers which are not loaded and ensure that they are fine. If they say no, you have to force keep it, you have to actually retain, then you have to actually ensure that don't touch on that. Okay. So check design, you will check you know um, for undriven inputs, multi-driven inputs, right? And you will check actually unloaded outputs. You can check basically um, you know some of the don't use cells if they are present. Clocks you can check, right? Uh, so things like that, you have to actually check in the design. And depending on, if you're running check design after placement, then it may check legality. You need to actually verify. And, so basically everything associated with the net list and get the area, get those sanctity clear. Check timing again, unconstrained endpoint, unclocked point.
If
You
there
can
is no
have,
input delay or
Input
output
or output
delay,
delay is delaying. Input or
yeah,
output delay missing for input.
unconstrained endpoints, and it will check for loops, unconstrained paths, multi-units.
yes. So you can check all that. So that's good. The next question is pin placement through GUI and command. Okay, so this again is a IO pin placement. So it's a direct command. Depending on the tool, we can answer that. But this is specific to the tool. We can discuss that separately. What you will do in ICC and so on and so forth. So I'm skipping that question because this is tool related. We can discuss that separately. So if you look at most of the questions where you're understanding how you are doing, what you have done, etc. Now let's look at the second set of questions. Okay. Now write a script to fix setup timing. Okay, this is your first question that they have asked. Okay. So what would be present in that script now?
Maybe for setup
Techniques for
upsizing of
reduce-
cells, we can mention through script.
How you will mention?
Upsizing
By using regular expression, we can take that cells and we can improve that. We can replace that
first we
names
have
with
to
this.
first we have to
HV.
get the cell
See,
which
you
have
should
to be
not
upsized.
always think like this is an ECO. At least you have to set that expectation upfront. Because every time you say setup fix, you are always talking about upsizing cells. Right? Where the setup timing failures are happening, whether it is happening, at placement, at CTS, I have always said this, right? Every single time I tell you, check where the failures are, whether it at which stage. You're always going into an ECO mode. At least you have to set that context. Okay, if the timing is all done, if the routing is done, and assuming this is at a final STA stage. If we are doing setup timing fixes at STA stage, this is the assumption. You have to first set the context. Okay.
Okay, sir.
It's all dumb answer. How many times I have answered? If it's placement and if there are setup timing violations, then how would you do it? Right? So at least you have to set the context. And here mostly the context is sign off timing. So if that's what it is, at least you have to first set the context. That's where you will gain the respect of your interviewer. Okay. Don't you would expect everybody to say that upsize. Okay. That's not the intelligence he's going to appreciate. At least you have to basically set the context. Okay, assuming all the route done, and this is we are talking about setup fixes, which is being done, at the time of sign off. Now, assuming it's come to the STA stage, right? So at least you have to set that context. Now, how do you go about fixing your timing? Already that question is answered. What is your order of timing fixes? Okay. Now, setup timing also you have to go by what is the quantum of your violation. You cannot blindly go and do upsize. Let's say a path is violating by 1 nanosecond. Okay. You will just go and upsize the cells and assume that it's going to fix. Okay. What is the problem? How would you first you have to add intelligence to the script? No, you have to classify your violations into certain things. How would you write a script to fix the violation? So I would say setup timing, if that is there, first I would actually order the report in terms of violations. Okay, what is the worst violation? To all the way down to 0. I put that in the descending order of violations. So first you have to order your report or your violations in those categories. Get all the endpoints. Okay. Just blindly upsize, how will you do in the cell? You tell me. In a script. Okay. You have to first classify the violation in terms of whether the violation is 1 nanosecond, 3 nanosecond, 500 picosecond or 100 picosecond, etc. You have to classify the violations accordingly. Okay. That's the first job of your script. Your script should actually sort the reports in the descending order. Once the report is sorted in the descending order, then I will look at buckets of violation. Let us say the violation is between 500 picosecond to 1 nanosecond. Okay. And if the case is this path is actually valid and you are seeing this violation, okay, then what you would look at is whether there is a then you would do, okay, this endpoint is violating by 1 nanosecond. Then you will actually write a get the register name. Let's say DPIN, the violation is 500 picosecond. Then for the same register, you will look at the clock pin and then you will check the skew. What is the skew? If the skew is actually bad, then where will be your fix? The majority of violation has come because of skew or because of crosstalk. You will have to edit the script accordingly. At least first you have to write the flow chart. Okay, you have to say what is your logic, how you are going to do, and before you adapt the script. Don't just go upsize, hold fix, add a buffer, endpoint. This is all stuck in your mind. At least Yajna and Lingeshwar, I appreciate you. You are trying to answer your question because you are still joining, you're still in training mode. Okay, you have not experienced a design. Okay, but I have explained this. So you have to actually first sort the report in descending order. That's what your script should do. Then, what it will do is your script should find out, wherever there are actually skew bugs. And if there is, a clock margin, let us say, for example, I have actually violation of 500 picosecond at the D pin. I will check at the Q pin of that, flop. And if there is 500 picosecond margin, then I will do a push that clock pin to 500. So that's the attack I'm going to do before I take upsizing. Okay. So I think we have to add some intelligence here. Okay. So setup timing fixes. You have to look at, you have to first address if there are actually bad trans cells. Okay. Anything, get all the cells, whose delays are more than 500, 600. So you can actually play that heuristics also. Get all that particular report. Okay. So not everyone should try to answer in same manner, but you will look at this. Upsize also. What will you upsize? Okay, not that path. You have to actually get every cell whose delay is more than 500 picosecond. And why is that cell more than 500 picosecond? Maybe it's a zero drive buffer. Okay, or maybe the net length cap load is too high. first you have to diagnose the problem, no? Like, somebody has come with a fever, you'll take a penicillin injection and just attack him. What will happen? What is the cause of the fever? You cannot just do a one injection solves all. You have to understand what the symptoms are. The temperature says 104 degrees. Yes. Oh, he's got 104 degrees. Give him penicillin injection or give him, some rabies injection. That's not a doctor. What's the cause of that? Why does the doctor ask you questions? What did you eat? What happened? He wants to understand what would be the possible sources of your problem before he goes. Otherwise, he will order everything scan. Go do MRI scan. Go do, Where is the engineers in you, man? So you can pick the cells which have actually more than 500. And if you say cap load, get the, get attribute cap at the load. If the load is very high, then there's a problem. Then there is a load problem. That means, either it is because of wire or because of fan out. Okay, you have to run that script. Okay, load is high. Or if the load is fine, if the load, how do you check whether it is high? Load should be like 5 femtofarad or something like that, or 10, whatever, 15 picofarad. Okay, if that is more than 15 picofarad, then go and diagnose. That's what you will put in the for another function. Okay, whether the problem is because it is driving hundreds of fan out, or the problem is because the wire is long. Okay, other diagnosis is it's failing because input transition is very high. Okay, if you are seeing that because input transition is high, you cannot do anything with that cell. So first you have to actually address the input transition problem. Why is that coming in? It's because the this driver may be weak. You have to actually fix the driver problem. If the cell is actually bad. Okay, that's what your script is supposed to do. So take this one question. I want actually everybody to make an attempt and come back with possible solutions. Okay.
Okay, sir.
Just go blindly upsize. Okay? Think about position. So any cell with 500, if it is a weak driver, then should I actually swap it or should I size it? That's also a question. Swapping will yield certain percentage. You should work in the design. 500 picosecond, you have a delay in the cell. Swaps.
అంటే ఇప్పుడు చేంజెస్ చేస్తానంటే మనం ఏం చేయాలి, జేసన్ ఎక్స్పెక్ట్ చేయకూడదు కదా. మనం అంటే జస్ట్ ఒక ఐడియా తీసుకోవాలి. కానీ మీరు ఆల్రెడీ శాంపుల్ రెస్పాన్స్ పంపించారు కదా, ఆ రెస్పాన్స్
Can you mute yourself? Yeah, thank you. Right. So try the one thing I want everybody to make an attempt is write a possible algorithm. Think about a flow chart. What way you are going to fix the setup violation once you are in the sign off mode? What are possible reasons? Okay, look at crosstalk, look at weak drivers, look at certain things, bad transition, etc., detour route. Okay, you have to write the script in accordance with that. Okay. Or you can even use your own heuristics. You can answer, no problem. I'm not going to touch anything more than 500 picosecond because I need more analysis for those paths. So I'm going to look at, the thing is, if there is actually simple paths which is actually less than 50 picosecond violation or some 20 picosecond violation, those paths you address it differently. You can look at, and if there are actually, let's say less than 50 picosecond, there are 100,000 paths. Okay, you sort out everything, you upsize, what will happen? How many unique cells are there? Okay. Whether those are all part of the common start point, then you push the clock, where there are common start point. Maybe the clock gate which is driving them, push them. So always the setup analysis, setup timing analysis, when you are looking, upsize should be your bottom half of fixing technique. It's not your top priority. That should not be your top option. That should be your bottom of the pyramid option. Your first priority is to understand if the paths are valid, then, can I attack? Is it because there are actually very bad transition, or is it because basically the clock skew has screwed up, right? Is it because net has detoured? You have to first eliminate these particular options before you are touching that particular path for anything else. Or is it because there is a crosstalk? Why? Those questions your script should take. Is that, is this pin seeing this float more than this? Then there's no answer. If that is answer, then okay, fine, go to the next question. That's how your script should operate. It should eliminate those options. And you build that. You can build a smart script. Okay. By blindly, I will say any net length more than 500 picosecond, 500 micron, go and buffer them. Okay. Add buffer on route. Okay. Scenic net, unless they are non-scenic nets. Okay. For all non-scenic nets, you do add buffer on route, whichever net has more than 500 micron or 200 micron, whatever is your technology dependent. We do that because long nets are getting broken down and you're violating paths. Any clock ran in that path, which is more than 100 picosecond, 200 picosecond, go fix them. You have to address them. Possibilities of 1 second. Okay, so think about this question and come back. Okay, and every setup has to be looked at that structure. As I said, sizing should be part of your bottom half of your problem. Okay, address the cap, address the stuff, look at the skew, and then you can go ahead and And also you have to look at all the bottlenecks. So think over, and then we can have a discussion about this. So what all information will be there in DEF? Any answers? What will be there in DEF?
Coordinates of the diarrhea, track information, blockages, then there bias nets, that those information.
What bias nets?
Bias via
Information.
tracks, blockages, then diarrhea coordinates.
What is the difference between DEF and LEF? What is there in DEF versus what will be there in LEF?
DEF will give detailed information, but LEF will only give the abstract information.
Detailed information.
We have DEF, sir.
Detailed information will be in DEF.
Every stage we have DEF. Design. Main
Can
difference
you
between
look
DEF
at
and LEF
any
is the DEF
difference?
we can.
If you want to use furtherly in the design, we will use DEF, sir. Suppose some of the floor plan information we have did in that thing, we can use that DEF, and again we will update that DEF thing to whatever that needed. We can use that DEF information. LEF is actually whenever we are using that LEF information is whenever that hierarchical runs will be there. We can use that LEF to the suppose Cryo L3 is one of the sub hierarchical. We can use left gold and gold plus. This is the hierarchical. These lefts we need to take care, and we will find the runs from top level. That purpose we will take care from those lefts.
Yeah. How you use is understood, but what is present in DEF is not at all answered. Okay. DEF will have actually
If there is any
location of the
subblock,
cell.
then
It will have actually, hello?
Yes, sir. It's audible.
It will have actually length of routes. Their own, so why don't you write a floor plan left versus floor plan DEF? Okay. So just analyze this, because I think, you are answering DEF from a left point of view. We will look at this in more detail. We'll open a LEF and DEF tomorrow, because, we'll spend some time. You can do some research also on this. Okay. Maybe one of you spend that time, look at what is there in LEF, look at what is there in DEF. Okay. You can get the information online itself before, and clearly specified. You have to ingrain this information in your mind. Okay. What is present in LEF? Okay. What is present in DEF which is not present in LEF? What is there? When you say detailed, what is detailed? Does it give you GDS level? It does not. DEF also does not have any base level layer information. No. DEF is more to do with all your connectivities. It will have those information. Okay. Understand what is the netlist, what is a DEF. Okay. What is a LEF, what is a GDS. This is also a homework. Spend that time. I want people to write essays and share. I'll keep this as an assignment and we will talk more. Let's look at the third point. If macro width and height is 100 micron, what is the coordinate of macro? What is the coordinate of macro? Hello?
Also, this macro coordinate, it depends like where we are placing this macro. The coordinate depends on that.
But the macro itself will have certain coordinate internal. Now he has given height is 100, width is 100. Correct. You have a point about its placement. Okay, that's one of the things that you can say that, but that is relative to it. But there's a native coordinate to it. No. What is the coordinate? It will be 0, 0, 100, 100.
Both be same.
Sorry?
X and Y values will be same for coordinates.
No, that will be the width and height. Initial coordinate is 0, 0. 0, 0, 100, 100.
Okay.
That will be the macro coordinate. Now, depending on where you're placing, that 0, 0 will change. Then this will be the added ones. Right?
Based on core to macro
Yes.
distance, we have some spacing we are giving.
So the fourth question, what is this metal stack? Right? So, I mean, this is also something you can do as a homework, but I'll give you a basic things. Initially, it has said 13M. That means it's a 13 metal layer. Okay. Then it says 1x, 1x, A1, Y, we can talk like, whenever there is one, that means one metal, you have to look at the now, what is that entire 13 metal talking about? So the first metal layer, it says, it's of X width. Then the second metal layer is again of X width. That is what is 1x. Next is 1x. Next is XA. And then, then there is 1Y, right? 1Y is again, YA is again another expression, whatever that YA would mean. You have to actually look at that. Then there is 5Y2. That means, after first metal layer M1, then second metal layer M2, that is also 1XA category. Then third metal M3 is of 1YA category. Then from M4 to M8, that is the next 5 metals is of Y2 type. Okay, M4 to M8 is of Y2 type. Y type. Then basically 2Y, 2YY. Then M9 and M10 are of YY type. That is what is 2. That means the next 2 metal layers. Then basically, you have actually next is UTRDL. So that is the 13 metal layer, right? So you can really look at this particular 13 metal actually given how that entire what rule it should follow. Okay, then M1 P57 as a definition. You can look at it. M2 P40 definition, M3 P44, and P76, M5 P76. Okay, these follows a similar stuff. We can look at these things, and it will tell you, H240 again is like I think that's for that standard cell, which is like 9-track cell. I think that is 9-track or 6-track. 9-track probably 240. So this again is there in the literature. You can just Google first and understand how the metal tracks are represented. Okay, but you can clearly answer this question. You won't be able to accurately answer in the interview. You can say this is how you are going to read 13 metal and this one. The details will be available in the PDK, and we can look at, at least you have to tell how you will be able to identify the. See, sometimes if the answer is not present, you don't know the answer. At least you should know how I'm going to get the answer. That's the way you have to answer that question in the interview. See, this will be present in the PDK. I can look at this rule deck, but this is how I'm going to read it. Okay. And the exact details, what this YA would represent is present in that particular rule deck. and it will tell like it is 1x width or something, and so on and so forth. All those details will be present, but this is the reading of it. Okay. So if you tell, then they would understand, you how to get your answers. You should not dumbly answer. You should not try to imagine or cook up a story, but answer it very engineering way. Okay. Then question number 5, commands to get one port to register. Okay. So let's look at, for example, cadence. Okay. Is asking get the register. So db get, you can say dot cell dot sequential. Okay. Or you can say get attribute, get, whichever you want to look at. So first you get the register, and then, get the get pins of minus objects. You can do that particular register, then you will get all the pins, and then, you have your answer. So first is the pin of the register, or you want actually register connected to the port, because he has said port. Does that mean which, if that register is actually traced back, that pin has to be traced back to the port, then you have to do a, get the entire path trace. You can do that. Okay. So I think probably here he means pin of the register. So you can answer that question very straight. What is there in timing report? What is there in timing report? Wait, what is the time now? 9:22. Only 5 more minutes I'll take. Then I'll give the break, because 9:30, no, I don't want to disturb. What is present in the timing report?
Point endpoint information. And get
In
triggered by
timing
which
report,
clock?
we have
We have start point,
Well-
end point, then that path.
Whether it is minimum path or maximum path. Min time path or max time path.
Yeah. So let's say, first of all, you have to answer this question. There are different timing reports. Okay. So whether we are talking about, report timing, right? You can actually report for setup, report for hold, report, report constraint all violators. That report will be different. So when you're looking at report timing minus max, what all information you can get? You can get all the information regarding the delay of the cell, whether you are meeting the setup or whether you are meeting the timing or not. What is the clock frequency you can get? You can look at the, you can report the entire clock path or just the, data path. Okay. If you do hyphen, full timing path, then the entire thing will come out. Then you can look at, get the information of the skew, get the information of crosstalk, right? All this information, and also you can get the information of derating. Okay. You have to do that, hyphen options and add all the options that is required. So in terms of timing report, you can derive all that, which are the start points, which are the end point. Yeah, all this information you can get. Okay, what type of registers were used, what types of cells are getting used. Okay, and where are the ports? You want actually hierarchical port information, that is also available. Okay, so you can get all those information from the timing report. What's the next question? Which one you use first method to fix setup, VT swap or size? Now this is a very precise question. What will you use? Whether you will do VT swapping or sizing, which is a preferred option?
If power is the not our concern, then swapping.
Sorry?
VT
If power is not our concern.
Yeah, so I mean, you would, as an intuitive question, you can answer it VT swap. It's fair, but you can add taglines, right? in one of the designs, basically, if it is already higher VT, okay, so if the leakage is a real concern, okay, because VT swapping will not disturb your routing. Okay. See, sometimes these questions could come from a PV guy. I mean, if I look at this first set of questions, it talks like he's more experienced in physical verification, integration guy. So that's why these questions are coming. So you can answer that question intuitively and, look at that. So sizing means, it's going to, whether you size it or swap it, power is going to increase irrespective. Okay. The only point is if your leakage, for HVT to LVT conversion, or SVT conversion is going to increase by 10x, then you are not supposed to do that. Okay. So you can intuitively, the answer is simple VT swap. But you can give this explanation so that he gets impressed. How will you run ECOs after ECO generating? I didn't understand what was this question. How will you run ECOs after ECO generating? Okay, so this looks like, what he's trying to say is, whether you will do ECO by netlist or ECO by file. Okay, so if there is again, this guy must be a PV guy. So if there is ECOs which are, there are two kinds. One is a functional ECO versus a timing ECO. This should be your first question. Are you talking about a functional ECO or are you talking about a timing ECO? If the answer is of timing ECO, okay, then what I will do is I'll first sanitize. I'll source the ECO, okay, into PT and check, if it has actually fixed the setup without impacting the hold or vice versa. And you are looking at, you have fast corner, you have slow corner. When you are doing setup fixes, I generally don't worry too much about hold initially, because hold can be fixed. But once I have started to fix hold, then I'll be sensitive to setup fixes not impacting any hold point. Okay. So initially I don't really care about that, but that's where it is. So I'll check if it has actually really fixed. Then it fixed, then I will take that in ICC and check if those cells, if the netlist, it's able to read if there are actually any errors in the ECO. And if it's like highly congested design, then I will look at, placing some cells manually. These are the ways, you are trying to answer this question. Okay. I think we are hitting the cutoff time. I will stop here. We'll answer the rest. Come back with your assignments tomorrow. Okay.
Okay, sir.
Hello. Yeah. Thank
Okay,
you.
sir.
Thank you, sir.
Yes, sir. Thank you.
Thank you, sir.